Welcome to the ITFreeTraining video on the differences between DHCP for IP4 and IP6. Even though DHCP for IP6 performs the same function as DHCP for IP4, there are a number of differences in how the two protocols work. Before I look at the difference, I will first start with looking at what is the same, or at least what is similar, between DHCP for IP4 and DHCP for IP6. There are three key components of DHCP. These are DHCP Client, DHCP Server, and DHCP Relay. The components do not change depending on which version of the Internet Protocol that you are using. In later videos, I will look at these three components in more detail, but essentially each component works like this. The DHCP Client is a device on the network that can utilize the DHCP protocol in order to obtain network configuration. The DHCP Server is a component which provides network configuration to a DHCP client. The DHCP Server is configured by an administrator with the network parameters set to meet their needs. The last component is DHCP Relay, more commonly referred to as the DHCP Relay Agent. When the DHCP client and the DHCP server are on different networks, they are separated by a router. The DHCP relay will pass the DHCP messages between the networks. Next, there are scopes and leases. In later videos, I will look at these concepts in more detail. DHCP for IP4 and IP6 both use these concepts. Basically, a scope is a collection of configuration information that is used to configure devices on the network. A lease determines how long a device on the network can use that configuration. The last similarity between DHCP for IP4 and IP6 is that they both use 4 messages to provide basic configuration to devices on the network. In later videos, I will look at how these messages work to configure a device in more detail. The important point to remember is that although the names of the messages in IP4 and IP6 are different, the basic concept of how they work is the same, but more on that in later videos. Now let's look at the differences between DHCP for IP4 and IP6. The first difference I will look at is reservations. I will cover reservations in a lot more detail in later videos, but essentially when an administrator creates a reservation, a device on the network will always get the same IP address. This is the same principle in both IP4 and IP6. In this case, I will use an example of a desktop on the network. In the case of IP4, the desktop has a network card. This network card has a MAC address. A MAC address is a unique number assigned to all network adapters, kind of like a serial number. The MAC address is used to work out which IP address to give to the desktop. So essentially what happens is that when a reservation is created in IP4, the MAC address is linked to an IP address. When the DHCP server receives a request from a device with this MAC address, the DHCP server will always assign that device the same IP address. For basic networking, having IP addresses allocated based on MAC addresses works really well. However, there are some problems that can occur later on, which IP6 looks to address. Let's consider the same example, except this time IP6 is being used. The desktop computer has a network card as before. Unlike IP4, rather than use the MAC address of the network card, the DUID and IAID are used. The DUID and IAID are essentially numbers, and in later videos I will look at how they are created. For the purpose of this video, I will simply look at what can be achieved using these two numbers. Using both the DUID and the IAID, an IP6 address can be allocated to the desktop. So the process looks much the same as with IP4. The difference is, let's say the network card in the computer were to fail. It is a simple matter to replace the existing network card with a new one. The problem with this approach is the new network card will have a new MAC address. The MAC address was a unique value that identified the device on the network and now has changed. In IP6, the DUID does not change when a network card changes. However, the new network card is given a new IAID. In both IP4 and IP6, the reservation will need to be updated. IP4 with the new MAC address and IP6 with the new IAID. So essentially with IP6, there is now a way to identify the device in the form of the DUID and the network interface in the form of an IAID. In later videos, I will look into more detail how the DUID and IAID are created. For the moment, know that DHCP for IP6 has a much more sophisticated method for reservation than IP4, which allows it to address many more scenarios than IP4. The next difference that I will look at is that IP6 comes with both stateful and stateless configuration. This essentially means there are two different methods that can be used to configure a device on the network. This may seem a little confusing at first, but it simply means that stateful stores device configuration, whereas stateless does not. Let's have a closer look. First, I will look at stateful. Consider that a server is set up on the network with DHCP installed. The objective of the DHCP server is to automatically provide network configuration to devices on the network. If you use IP4 with DHCP, it will be considered to be stateful. If you use IP6, you will have the choice to run DHCP as either stateful or stateless. So what does it mean when the server is running in stateful mode? In this case, DHCP is installed on a server. The server knows the IP addresses of all devices on the network. It knows them because when the DHCP server allocates an IP address, it records which device on the network it gave that IP address to. This ensures that two devices on the network are not allocated the same IP address. With DHCP on IP6, a new mode of operation is supported called stateless. This is generally used on routers. Stateless works differently from stateful in that it does not record which devices on the network are using which IP addresses. Devices still need some configuration information, so messages called router advertisements are periodically sent to all devices on the network. A device will use this router advertisement message to configure itself with an IP address. Part of the IP address the device will decide for itself. The final IP address that the device decides to use is not recorded when stateless mode is used. In IP4, it was not possible for devices to configure part of their IP addresses themselves, due to the limited number of usable addresses. In IP6, there is not a shortage of IP addresses, so it is possible for devices to configure their own IP address. The idea behind stateless is that a router should be able to provide enough configuration information to devices on the network so that the device can configure itself. However, if you want to configure additional network configuration, stateful mode may need to be used. In later videos, I will go into this in more detail. The next change between DHCP IP4 and IP6 is that IP6 uses multicast rather than broadcast. Broadcast packets go to all nodes on the network. In IP4, when a device is added to the network and it attempts to get network configuration, since it has no network configuration, it will send a broadcast to all nodes on the network. The objective of this broadcast is to locate a DHCP server. There may only be one DHCP server on the network, but hundreds of devices on that same network. So you can imagine data is being sent to potentially hundreds of devices when it is only required by one device. This can be a very wasteful use of network resources. IP6 fixes this by using multicast messages. Multicast messages are sent to selected nodes rather than all nodes on the network. For example, if a node wants to locate a DHCP server, the multicast would be sent to only nodes that have asked to receive that kind of traffic. This reduces the amount of traffic that is sent on the network. This is particularly important on large networks that have a lot of devices. Well, that is it for the major differences between DHCP for IP4 and IP6. In later videos, I will go into more details about the topics covered in this video. I hope to see you in those videos. Until then, I would like to thank you for watching.